This video is brought to you by mywayteaching.com.
Next topic is percentage composition. Okay, so next topic is percentage composition. Before explaining about the percentage composition, so why this percentage composition required and all, I will explain you. Okay, so far we were dealing with the number of entities present in a given sample. Whatever the entities are present in a given sample, we were calculating that, correct? Whatever the atoms present in that, if they are giving a molecular mass, molecular formula, so if they are giving a formula, means we are calculating the whatever how much mass, molecular mass we are calculating in, means by considering the number of atoms in it and its atomic masses, just we are calculating like that. So but many a time the information regarding the percentage of a particular element present in a compound is required. Right, every each and every time we require the what information about the every compound we require. So it is required. Suppose an unknown or new compound is given to you. Okay, if any unknown compound is given to you, means so you will have some of the questions like what is its formula, correct, or what are its constituents, and in what ratio the compound is, what are the ratio of elements are present, like this you are having some of like this. Okay, for known compound also such information is provides. Check whether the given sample contains the same percentage of elements as is present in a pure sample. In other words, we can check the purity of a given sample by analyzing this data. Okay, so before going to okay, so the next is uh, let us consider understand it by taking the example of water. Since water contains hydrogen and oxygen, the percentage of the composition of both these elements can be calculated as follows: mass percentage of an element is equal to mass of that element in the compound into 100 divided by molar mass of the compound. Okay, mass of this and mass of that element in the compound into molar mass of the compound. So just by taking the example of water, we can say that we can calculate the percentage composition. Formula we know for this mass of molar mass of water. The formula for this, again I will write it down: mass of that element in the compound, percentage of an element is equal to mass of that element into 100 divided by molar mass of the compound. Okay, so this molar mass of the compound. Example for this, water. So first you should calculate the molar mass of the water. How to calculate molar mass of the water? So molar mass of water is equal to, we know, 18.02 gram molar mass of water. This is standard. Then we have to calculate by using this formula. First we have to calculate about the mass percentage of hydrogen. Mass percentage of hydrogen is equal to, we know, 2, how much it is, H2O, 2 into mass of the what mass of the hydrogen is 1.008. So mass of that element, 2 into 1.008, this is into 100 divided by molar mass of the compound is 18.02. gram. So how much you are getting? Mass of hydrogen is 11.18. We are getting like second one, mass percentage of oxygen. So oxygen is 1 and its atomic mass is what is 16.00 into 100, so divided by 18.02. Molar mass of water you are getting 88.79. So this is how we calculating percentage mass. Okay, then another example, consider what is the percentage of carbon, hydrogen and oxygen in ethanol. The second one is, what is percentage of carbon, what is the percentage of carbon, hydrogen and oxygen in ethanol. Okay, so molecular mass, first you consider the molecular mass of ethanol. Okay, in that two, so molecular mass of okay, what is molecular ethanol? C2H5OH. So this is molecular mass. So how to calculate the molar mass? Mass of ethanol is important. 2 into atomic mass of hydrogen 12.01 plus 5 into atomic mass of carbon. This is atomic mass of carbon and this is 1.008 plus for oxygen is 16. Okay, here okay, 16 again plus another hydrogen is there, 1 into 1.008, like this you should take. So by calculating this, how much you are getting? 46.068 gram. Okay, so ethanol, this is one example how to calculate the mass percentage of an element. Now you got the molar mass, then of that element, in that you have calculate carbon, hydrogen and oxygen they are asking. So carbon, how much it is there? 2 into 12.01 into 100 as in the formula. So this is molar mass is 46.068. so how much you are getting? Percentage of carbon, mass percentage of carbon is now 52.14%. Okay, next, the mass percentage of hydrogen. Now how many hydrogen are there? 6 hydrogen atoms, so that 1.008 into 100 divided by 46.068, how much you are getting? 13.13 percentage. By calculating 6 into 1.008 into 100, this getting. Next, mass percentage of oxygen is 1600 gram. Okay, divided by 46.068 gram into 100, so gram cancel. By calculating this, you are getting 34.73 percentage. So after understanding the calculation of percentage of mass, let us now see that what information can be obtained from the percentage composition data. Okay, so this is about percentage composition. Percentage composition, just remember this formula. Okay, mass percentage of an element, how to calculate. Then this is a by example for water, how we have to calculate. This is one example. Next, this is second example. Okay, so this is how to calculate mass percentage of carbon is this much, like mass percentage of hydrogen, and this is mass percentage of oxygen. Okay, next, Next topic is empirical formula for molecular formula. What do you mean by empirical formula and what do you mean by molecular formula? So this is important. Okay, before going to solve the problem, first you should know what is mean by empirical formula and molecular formula. Okay, so first come to the empirical formula, how to calculate empirical formula and all. Okay, so here empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. So empirical formula represents the simplest whole number. Empirical formula represents the what? Simplest whole number ratio, which represents the simplest whole number ratio, so of various atoms present in a compound. This is about empirical formula. Simplest whole number ratio it represents. Then molecular formula, in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound, which shows exact number. Okay, exact number of different types of atoms, exact number of different types of atoms. So if the mass percent of various elements present in a compound is known, its empirical formula can be calculated. If we know the mass percentage of if we know the if we know the mass percentage of various elements, if we know the mass percentage of various element, we can calculate the empirical formula can be further obtained if the molar mass is known. So molecular formula can also be calculated if we know the molar mass. If we know the so by this is the as after understanding calculation percentage of mass, now let us now see what information can be obtained from the percentage of composition data. Means mass percentage of element if we know, then we can calculate the empirical formula. From this again further we can calculate the molecular formula if we know the molar mass. So this is about empirical formula and this is about molecular formula. So okay, next one, how this is the problem statement. Okay, in this problem a compound contains 4.07 percentage of hydrogen, 27.27% carbon, 71.65% chlorine. Its molar mass is given 98.96 gram. What is the empirical and molecular formulas? Okay, here we have to calculate the empirical formula and molecular formula. So as we know, as I said, this is mass percentage of element they have given. Okay, and we have to calculate empirical formula and molecular formula, and we also know the molar mass. They have given the molar mass as 98.96 gram as a molar mass. So by that question, so in that they have given solution for that question is they have given 4.07 percentage of hydrogen. Okay, next 24.27 percentage of carbon and 71.65 percentage of chlorine. Okay, so the molar mass is 98.96 gram. So note down the steps involved in this. Step 1, conversion of mass percentage to grams. Convert mass percentage into grams. Okay, mass percentage into grams. This is the first step. Since we are having mass percent, it is convenient to use 100 gram of compound as the starting material. Okay, so thus in the 100 gram sample of the above compound, 4.07 gram hydrogen is present. Next, 24.27 gram of carbon is present, 71.65 gram of chlorine is present. So convert the mass percentage into grams. Next, step 2. Okay, so in step 2, convert into mass, convert into number moles of each element. Convert into number moles of each element. Okay, so in this step, here divide the masses obtained above by respective atomic masses of various elements. These are the masses, so they should be divided by its atomic masses. Okay, the first one is 0.407 gram of hydrogen. Its atomic mass is 1.008 gram. Okay, then the second one is 24.27. Its carbon atomic is 12.01 gram. Okay, so this is also in gram, this is also in gram. And the third one is chlorine atomic mass is, they have given 71.65 gram, so its atomic mass is 35.5453 gram. Okay, so for this, just by dividing it, we are getting here 4.04, 2.021, and for the chlorine we are obtaining 2.021. So in the second step, first to convert the masses into, first convert masses into grams. Okay, then convert into moles of each element. Like what, for this step you should mass, the given mass formula for this, given mass divided by atomic mass of those elements. Okay, so from this you can calculate. This is a step 2. Next is step 3. Okay, divide the mole value obtained above by the smallest number. Divide the mole value obtained the smallest number. Third step, divide the mole value obtained by the smallest number. Okay, so means since here which is having 2.021 is the smallest value, which is the smallest value. Okay, so here just consider, either both are having 2.021, both are smallest number. So if it is divided by this, all are should be divided by the smallest number, we are getting 2:1:1 ratio. So this is the third point, means how we are getting 2:1:1. So this is hydrogen is to C is to carbon is to chlorine. So in case the ratios are not whole numbers, then they may be converted into whole number by multiplying with suitable coefficient. So this is about step 3. Next, move on to the step Step 4. So in step 4, write empirical formula. Okay. Empirical formula by mentioning the numbers after writing the symbols of the respective elements. How to write empirical formula? C. Consider C only one atom. So H, which is having 2, and Cl, which is having one atom. So this is how to write the empirical formula. Then next is step 5, writing about molecular formula. How to write a molecular formula. Okay, so this is step 5. So in molecular formula, that first one, determine empirical formula first. Okay, empirical formula: mass. Add the atomic masses of various atoms present in the empirical formula. Second is add atomic masses of various elements, various atoms, various atoms. Okay, various atoms present in the empirical formula. So we know the empirical formula is CCH2Cl. Okay, so first one is determine the empirical formula mass. How to determine? 1 into carbon is 12.01 plus 2 into hydrogen atomic mass is 1.008 plus chlorine is 35.453. You should know what are the atomic masses of each element. Okay, so from this you can calculate the empirical formula mass as 49.48 gram. Okay, so in that first step is over, and the second one is divide molar mass by empirical formula mass. Okay, divide the molar mass. So like molar mass, in that molar mass divided by empirical formula mass. The molar mass they have given 98.96 gram, divided by 49.48 gram. Okay, so this is the empirical formula mass. In that we are getting 2 is equal to, this is the value of n. This is a step A. In that, this is step B. Next one is step, okay, this is step A and this is step B. Next, in step C, the last step is C. Okay, in that, multiplying empirical formula by n obtained above to get the molecular formula. So we know CH2Cl, where n is equal to 2. If it is multiplied, means C2H4Cl2. So this is the molecular formula. Okay, so please concentrate from the above. So this is the statement of the problem. So in that you should know the solution for this. This is the step 1, and step 2, convert and then divide. This is the ratio. This is step 3, to obtain, divide the mole value obtained by the smallest number. This is 2.021. How this is empirical formula, writing by using this one. Step 2, molecular formula. Step 5, and then determine the empirical formula mass. Add the atomic masses of various atoms present in the empirical formula. This is over.